Hello and welcome back to my Keypad integration series. In the last video, we were successfully able to add a second 7-segment display to our project so that when we press one key, that information is stored in a register so that when we press the second key, it will move over to P0 and the new key will display out on P2. Now we're going to start working on multiplexing. So instead of using two separate ports to drive two separate 7-segment displays, we're going to start using just a single port to drive both of these displays. But we're going to use this port, one of these two ports, to act as control signals that are connected up to the common bases of both of these 7-segment displays. And when the control signal for this line goes high, this display will show up. And when the second control line goes high, the second one will show up. So both numbers are actually going to come out of port 0, but one at a time, and only when the common base is selected for each one of these 7-segment displays. I've already started that process on the chip that we currently have installed, and I'll display that by simply adding some LEDs here to port 3, port 3.0, and port 3.1. There's one of them, and there's the other one. As you can see, those two 7-segment displays are strobing because I simply added a little bit of code at the top of the program here that clears and sets each one of these bits so that they're blinking. Now, if I was to connect those up to the two 7-segment display common bases, these two numbers would blink. So let's go ahead and do that. First, I'm going to remove power. I'm going to remove the two resistors that are connected to the bases. We're going to plug these lines. Let me move this out a little bit and make this a little easier. This one. Port 0 will go over to here. And then port 1, not port 1, it's actually port 3.1, will go over to there. Got that in there right? Nope. Move it over one. Now when I plug this in, and hit reset, looks like I missed just by a little bit. Things are so small, it's easy to misplace them. Okay, try it again. We'll reset. Now you can see the two 7-segment displays are blinking, but they're very dim, so it's really hard to see what numbers are coming out of there. And that's because, we're not tying them directly to high. They're getting their high signal from the AT89C51, which is not, exactly supposed to be used as a driver. So we have a way of fixing that, and I'll show you that later. Right now, this is basically a tutorial on multiplexing, and as you can see, our signals are being sequenced one at a time. We're still driving everything out of two parallel or two ports, but what we're going to do is get rid of this port wire these two 7-segment displays in parallel, meaning we're going to connect the A's and the B's and the C's together, so whenever a signal comes out, it actually goes to both chips, but it'll only turn on one at a time, depending on which control line is high. So let me take this apart and wire this in parallel, and then we'll start multiplexing for real. Okay, let's look at the simple bit of code that I added to simulate multiplexing our two control lines on port P3. Here we have multiplex 1, where we clear pin P3.0 and we set pin P3.1. That'll turn on one of our LEDs. Then we call a nice long delay, and then we set P3.0 and clear P3.1, and that will turn on the second LED and turn off the first LED. And that just simply keeps repeating, so neither one of our LEDs is on at the same time. There's always one on and one off. And that simulates our control lines that we're going to be using to multiplex our two 7-segment displays using one port to put out the 7-segment display code to both displays. So let's take a look at that code real quick. What we first had to do was change up our display program just a little bit, because we can no longer just send it out to a display because everything's going to be going out of port 0. So what we do is, we get our display right here. It tells us which is our 7-segment codes to use, and we're going to store that now in R2. I also store that in R7 for later use. So when we press the second key, it will actually go out on R3. But during this first key press, I'm setting R3 to a 7-segment code of 0. That way we always know when the first key is being pressed, the second digit is always going to be 0, and we'll see just the first key. And then down here on display 2, we do the same thing. We get the new number and we put that in R2. Now we're going to move R7 to A and move A into R3 so that we can display the first key pressed on R3 and the new key pressed on R2. Then of course we reset our counter, call a delay, and jump back up to the top. Now here's where we're actually displaying everything out of port 0. We've already spoke about multi-1 and multi-2, where we're setting one control line high and one control line low. Then we're setting the other one low and then the other control line high. So only one of these displays, one of these are going to be displayed at a single time. Now we're going to put R2 on P0 during this cycle, or during multi-1, call our delay, and then we're going to put R3 out on P0 when we're in multi-2 cycle. And that's all there is to multiplexing, really. Pretty simple. But we do have to make some changes to our breadboard, so let's take a look at that. Okay, now we're ready to start multiplexing for real, but we have to make a few changes to our breadboard, as we're going to only be sending out all of our data through P0 here. We had to set our two 7-segment displays up in parallel by adding little jumper wires from A to A, B to B, C to C, D to D, E to E, F to F, and G to G up there. So we've done that already, and we're ready to just hook up our control lines to each one of these 7-segment displays. So the very first one, P0.0, goes up here. Find the right hole for it. And then P3.1 goes to our second 7-segment display right here. And just make sure I got the first one in the right place. Looks like I do. And now we're ready to actually see multiplexing in action. Let's plug this in. And okay, you can see both of our 7-segment displays. I mean, they're very dim right now, but we're going to fix that problem shortly. But let's see, if we press a 1, we got a 0, 1, and now we got a 1, 2 in our two 7-segment displays. So both of the numbers are coming out successfully and only being displayed on the correct 7-segment display. Now all we have to do is decrease the delay so that they're both look like they're on at the same time. There's our 4, 5, our 7, 8, and our E0. Now, I don't know if you can see this. Again, the displays are very dim because we're trying to, drive these 7-segment displays just using the control lines by themselves. There we go. So that is multiplexing. Now, there's a simpler way of doing this instead of, tying all these, having to tie these ports all into parallel. You can simply buy a 2-digit 7-segment display, such as this one, that has 10 pins on it. That's 8 pins that are already tied in parallel and 2 control pins. Now I can't, every single one to me seems to be that, you have to figure out where the control pins are and where each segment is located. But once you have that down, you can plug it in and get everything working. And this is a little bit smaller than the ones we have, which is great because now, once we put this in here, we have more space on our board for maybe even more 7-segment displays. So let me get this one hooked up, and we'll start working with this one that's already tied in parallel. And then I'll show you also how to get these dim displays to show up a little bit better. We're going to basically be adding a small transistor and a couple of resistors to and tie them to the control bases here, or the common bases, to have them tied up to the power rail so they get more power. So let me take this apart and put it back together, and I'll be right back. Okay, I've wired up our new 2-digit 7-segment display and got rid of all of the wires that I needed to wire them in parallel. And that becomes important because as you add more digits, you don't want to keep adding more wires to tie them in parallel when you can just get, a 2-digit 7-segment display that's already in parallel, or even a 4-digit display that's already in parallel. Again, when you're looking to purchase these things, just look for something that has 8 pins plus the number of digits, so if it's a 4-digit, you want 8 plus 4, or if it's just a 2-digit, you want 8 plus 2. So make sure you pay attention to that. And of course, you want to make sure if it's common anode or common cathode. I use common anode here. So let's plug this in and see what happens. Hit reset. You can see we're still blinking slow, and you can see the two 7-segment displays flipping back and forth there. I guess you can see it, but they're kind of dim. And when I press the numbers, the number 1 just went into the first digit. Now the number 1 moved over to the second digit, and the number 2 is in the first digit. Now, I told you I was going to show you how to, increase the brightness on those. So let me get that wired up. Like I said, I'm going to be using this transistor and a couple of resistors, and tie these control signals to this transistor base to drive the 2 separate 7-segment displays. So let me get that hooked up and I'll show that to you. Okay, I've added my transistors here. As you can see, I have a 100 ohm resistor connected to the collector and straight to the positive rail. I also have a 1K resistor back here that's also connected to the collector, and it also connects to the base. And you can see my control line is going to the base of this transistor, and the emitter is just going straight over to the common base of the one section of the 7-segment display. So let's turn this around and see how that looks now. Okay, I'm going to do a reset. Okay, as you can see, our 7-segment displays are lighting up a lot better now, and we can actually see them. Basically, it's like when your control line goes high, it's like connecting that 7-segment display straight to high through a resistor. So that's how we're able to increase the intensity of the 7-segment display. So now that we have multitasking and our 7-segment displays lighting up, now it's time to just increase the speed of these two control lines so that it looks like both 7-segment displays are being driven at the same time. So let me power this off. See, pull this chip out. And put this one in. Okay, with this chip, all we've done is decrease the delay in between the time that each of these control lines goes high. And it looks like both 7-segment displays are actually lit up at the same time, but they're really not. They're still taking turns. They're just doing it so fast that we can't see it. Well, that looks good there. So hopefully that explains multiplexing and actually the need for the transistors to help you out there a little bit on driving the 7-segment displays. Hope that everybody was able to follow that, and in our next video we're going to add 4 more 7-segment displays to the mix. That ought to make things a little bit more exciting. So stay tuned. I'm also going to probably rewire this thing so that we don't have wires, those purple wires and those green wires all over the place, where we can actually see all of our 7-segment displays. So stay tuned. Thanks for watching.